To solve a rational equation, our goal is going to be to get rid of the denominators. So like this x and this 3x and 3. If we can cancel those by creating an equivalent equation, it'll probably be easier to solve. I'd say the easiest way to do this is to determine the least common denominator between these three fractions. It's pretty easy. You have an x, you have a 3, and a 3x. Clearly 3x is the least common denominator. If we multiply 3x to both sides of this equation, each denominator will cancel and there will not be anything extra left over. So that's what's stated in this fact up here. To solve this equation, find the least common denominator and multiply it to both sides. That is, we get 3x over 1. That gets multiplied to the 2 over x. Then it would be distributed to the, so we'd have 3x over 1 is multiplied to 1 over 3x. And on the other side of the equation, we have, again, 3x over 1. That's being multiplied to 1/3. If we did this correctly, every denominator should cancel. So that x cancels with that x, the 3x cancels with the 3x, and 3 goes into itself once, and all the places of those marks are just a 1 that's being multiplied in. So from our first fractions, we get 3 times 2, which is 6. Plus, we have 1 times 1, and I'll divide by 1, that's just 1. And on the other side of my equation, I have x times 1, which I'll just put as x. This actually is simplified really easily. By multiplying both sides by the least common denominator, it changed it to this linear equation whose solution is 7. And I stated that we should plug this number into the expression just to make sure that it makes the left side equal the right side. So I'll do this once here. I think it's simple enough in this equation where it's 2 over 7 plus 1 over 3 times 7. That should be equal to 1/3. Is this in fact true? So let's see, 2/7 plus 1 over 21. Is that 1/3? That means I'm multiplying the first fraction by 3, so 3 over 3, which gives me 6 over 21 plus 1 over 21. Is that equal to 1/3? That's 7 over 21. Is that 1/3? And the answer is yes, because 7 goes into 21 3 times. We do in fact get that 1/3 is equal to 1/3. When you know 7 is in fact the solution. So this was just a way to check our work. But really, as long as we did every step here okay, there's only one thing to look out for, and that's something called an extraneous solution. If you look at this equation, I know ahead of time there's exactly one number that I could not use, and that number is 0. If you put 0 in place of either of those x's, you would be dividing by 0, which is impossible. So just as maybe a good first step would be to ask yourself what numbers make the denominator 0. You cannot use those numbers in the original equation. But that aside, we'll encounter that maybe in another equation in this lesson. All right, so let's try this idea maybe in a slightly more complicated equation like this one here. If I look at the denominators, again, my goal is to multiply by the least common denominator. Like, what is that? And I'm not quite sure because the first denominator is not factored. So I'm going to factor that denominator. The equation is x squared minus 5 over, and x squared minus x minus 2 is x minus 2 times x plus 1. Then I have on the other side 1 plus 3 over x minus 2. I can't factor anything over here. And now I can see what the least common denominator is supposed to be equal to. It should be x minus 2 times x plus 1. That will cancel every single denominator. So I'm also going to make note of something. The answers cannot be 2 or -1. Sorry, that was x equals positive 2, x equals -1. Cannot be solutions. And I'm just making note of this from the fact that if you were to put 2 in place of this x, 2 minus 2 is 0, and you cannot divide by 0. Likewise, -1 in place of this x, -1 plus 1 is 0. 0 times this piece is going to be 0. Any number that makes a denominator 0 cannot be used. But going back to the previous example, I'm going to take this least common denominator and I'm going to multiply it to every single term. We have x minus 2 times x plus 1 over 1. That's multiplied to our first fraction, x squared minus 5 over x minus 2 times x plus 1. Okay, that is equal to, then we have again x minus 2 times x plus 1. You could write all over 1, but that whole thing is being multiplied to 1. Then we have plus, okay, again we have x minus 2 times x plus 1 being multiplied to the very last term here, which is 3 over x minus 2. This is the setup, quite a lot of writing, but what cancels are the x minus 2's, the x plus 1's. That's nice. I don't have to worry about anything in this second piece. In fact, who even cares about the denominator since I don't even have one here? But in my very last term, I have x minus 2 canceling with that x minus 2. Here's what is left over. From this very first product, it's just x squared minus 5. Everything else is just 1. So we have x squared minus 5. Okay, this is equal to, over here, I just have x minus 2 times x plus 1. And then here, I have 3 times x plus 1. All right, let's solve this thing. What I'm going to do is distribute this, and that really should be equal to x squared minus x minus 2. So let's do that. On the left, I have x squared minus 5 is equal to x squared minus x minus 2 plus 3x plus 3 if I distribute the 3 into the parentheses. Okay, I'll combine some like terms. I have x squared minus 5 is equal to x squared. Okay, we get plus 2x plus 1. I can subtract x squared from both sides. That leaves me with negative 5 is equal to 2x plus 1. I'll subtract 1. I get negative 6 is equal to 2x, and after I divide both sides by 2, I get my answer, that negative 3 is equal to x. All right, we could plug this into the original equation just to make sure it makes the left side equal to the right side. But really, since this number was not positive 2 or negative 1, I'm going to trust this process and say that negative 3 is my solution. If I encountered this number or this number, I would have to throw it away and say the equation had no solutions. So let's try this again where it almost looks like I just copied down the exact same equation. In fact, I did, but I'm going to make one minor adjustment. What if I had a plus instead of a minus? Would a minor change like this adjust the solutions to my equation? The answer is probably yes. Okay, I want to go through this problem just a little bit more quickly this time, since we essentially did the entire thing in the previous example. So by that I mean, I know the least common denominator is already going to be x plus 1 times x minus 2, or x minus 2 times x plus 1, whatever. And since this thing gets multiplied to these three terms, I know it's going to cancel ahead of time. When I multiply this to this fraction, the denominators completely go away. By that I mean all that's left over is x squared plus 5. If I multiply this least common denominator to this 1, I'm left with x plus 1 times x minus 2. But we already know that's going to be equal to x squared minus x minus 2, so I'm just going to copy that down. Then we have plus. Okay, as we saw last time, if you multiply this here, the x minus 2's cancel and you're left over with an x plus 1. So I'm going to have 3 times x plus 1. As we work through some of these problems with rational equations, It'll save you a lot of writing if you know what is going to cancel within the denominators. After some practice, you probably can go from this step to this one without writing a bunch of middle steps. Well, that in mind, I'm going to now try to solve this equation. Let's see, I'll distribute this 3 to both terms. Let's see what we get. X squared plus 5 is equal to x squared minus x minus 2 plus 3x plus 3. All right, combining some like terms, we get x squared, again, plus 2x plus 1. I can subtract x squared from both sides. So I get 5 is equal to 2x plus 1. And if I subtract 1 from both sides, I get 4 is equal to 2x. And after I divide both sides by 2, my answer is x is equal to 2. But there's a problem. If I take this number and I put it in place of all of the x's, you have to put that 2 right here. You get 2 minus 2 in the denominator, which creates 0. Plugging 2 into this equation makes this fraction have a 0 in the denominator. So actually, this is an extraneous solution. That really means it's not a solution at all. It's just some type of number that shows up in this process. And because it makes the denominator 0, we just throw it away. So the actual answer to this problem is there are no solutions. And that is it.